In this section, we're talking about what a derivative means and we're relating it to a certain situation. So number 1 says C of T is the cost to heat a house in dollars per day when the average outside temperature is T degrees. Interpret C prime of 23 equals negative 0.17. So C of T is the function, and whatever that is always equals whatever the y is representing in the problem. T is like the x, so that means that C of T, which stands for y, that means that C has to do with what the y value is. So in this problem, y represents cost and temperature represents x. So it wants me to interpret C prime of 23. Okay, start with whatever's in parentheses, that's 23. I know that because it's in parentheses here, those two things represent the same thing. So when the temperature is 23 degrees, and we're probably talking about Celsius here, then whatever y is, which in this case is cost, it does something. See, we're talking about C prime. Since that says C prime, there is a prime right there. That means that we're talking about the rate of something. So we talk about, okay, what's happening with x, that's the 23 degrees, and then we say what y is doing. Now, because we have a negative 0.17, that's the rate of change, that's how fast something is changing. That means that cost is decreasing. Since there's a negative in front of it, that means that cost is decreasing. So whatever y is decreases by 0.17 per whatever x represents. So since we're talking about degrees, that means per degree. So what that's saying is that as the temperature outside increases by 1, so like at 23 degrees, if I talked about what was happening at 24 degrees, then the cost would decrease to heat the house by 0.17 per degree. That makes sense because as it gets warmer outside, it won't cost as much to heat the house because it's getting warmer. I know these are kind of weird, but hopefully as we go through all of the problems that you'll see that it'll make a little bit more sense. Alright, so on this next one, talking about population, I want you to see there is a prime right there. I know it's hard to see on here, but there is a prime, so I'm just going to make sure you can recognize that. Alright, population, P of T, is the population in millions of the U.S. T years after 1800. Interpret P prime of 10 equals 23. Okay, normally I just start by figuring out what x and y is. X is whatever's in parentheses, it's the T, which is the years. Y has to be the P, the big P. And that represents population. So start off with what's in parentheses. We have the 10. I know that X represents years. So that 10 is representing the years after 1800. So we're talking about in 1810. We're talking about in the year 1810. We talk about what y does because y is the thing that is increasing or decreasing. So since we're talking about population, that means that population, it's increasing since I have a positive 23. So it's increasing by 23 per whatever x represents per year. And so, in other words, that's saying that if I went another year, like in 1811, then I would add 23, this is actually million, for the next year. So every year, the population is increasing by 23 million. Units are very important on these problems, so be very careful and think about them as you're doing them. Okay, number 3. D of T represents the depth in meters of the water in the deep end of the swimming pool, T hours after noon on Labor Day. Alright, I want you to notice that A says D of 1 equals 3, B says D prime of 1, so there's a prime right there, equals negative 0.5, and C says estimate D of 2. So let's just start back over here. I know that X represents whatever's in parentheses, it's the T, And in the problem, that tells me that that is hours. Y represents the D, which is the depth in meters. So on A, this is just something typical. This is not talking about a rate since there's not a prime. So D of 1 equals 3. The 1 is the X. So 1 hour, and then it tells me that it's hours afternoon. So 1 hour afternoon, which really means 1 o'clock. 3 represents the Y, which is the depth. So there are 3 meters of water in the pool. Alright, the B part. I still start off with whatever's in parentheses. So at 1 p.m., because it's a prime, it's something that's increasing or decreasing. I see it's negative 0.5, so something is decreasing. So that means that the Y, which is the depth is decreasing by 0.5. Alright, the units of depth is meters, so it's meters per whatever the units of X are, which is hours. So at 1 o'clock, the depth is decreasing by 0.5 meters per hour. Now that does not to say that at 2 o'clock the depth could be increasing by 1 meter. We don't know what's happening at all the other times. We only know at that one time what's going on. Now some possibilities about why that could be happening. It's Labor Day. Maybe they're draining the pool, and maybe it continues to decrease the rest of the day. Maybe somebody jumped in the pool and then decided, okay, now several people need to get out because they need to go eat, and so the water decreased when all these people got out. So that could be lots of different situations. We don't know because we don't know what the rest of the things happened. Now C asks us to estimate D of 2, and we have to just estimate it based on the information we have, meaning we're just going to continue it and hope that whatever is happening is going to continue to happen if we estimate. So we're starting at 3 at 1 o'clock. It wants to know what's happening at 2 o'clock. So we want to know 1 hour later what's happening. Well, if B is true and the depth decreases by 0.5 meters per hour, then what I need to do is I need to subtract 0.5 from 3 to find out that at 2 o'clock that there are 2.5 meters in the pool. Alright, let's look at number 4. Let H of T represent the time in hours between sunrise and sunset T days after January the 1st. Alright, just real quick to talk about that. If you're talking about sunrise and sunset, you know in the summer how the days seem really long and sunset's really late, and as you get closer to winter, the sunset comes shorter. It's nighttime at 5 or 6 o'clock before it is like in the summer. So that's what that's talking about, the hours between sunrise and sunset, how that changes. And so in the winter it's really short, and as you go toward the summer it gets really long and then starts getting short again. So we're going to start with figuring out what X is and what Y is. X represents the T because that's what's in parentheses. That represents hours. Y represents the H. And I told you that the T was hours. That's not true. The T is days. I just didn't pay attention there. The H represents the hours. So X represents the days at whatever day of the year it is. Y represents how many hours there are between sunrise and sunset. Okay, on A it says interpret H prime, there is a prime there, of 100 equals 0.05. So we're talking about the rate of how something is changing. The 100 represents 100 days after January 1st. If I really wanted to figure out what that was, well, there's 31 days in January, there's 28 typically in February, so we're up to about 60, a little less. 31 in March, so we're almost to 90, so this is sometime in April when we're talking about. So 100 days after January 1st, the number of hours, which is the Y, increase since we have a positive, by 0.05. The Y units are hours, so it's hours per day. So every day, sunrise and sunset's getting just a little bit longer, and that makes sense because by March, it's getting ready to be spring, and our days will start getting longer again. All right, next one says estimate H of 104. So on the 104th day, how many hours there would be at sunset if on the 100th day there's 8 hours between sunrise and sunset. So on the 100th day there's 8. 4 more days later, I'm going to increase it by 0.05. So every day I'm going to add 0.05 till I get to 104. You could just add 0.05 4 times, or you can multiply it, and you get 8.2. 5. The cost of building a house, A, feet squared, in area, is C equals F of A. What are the units of F prime of A? So here we're just talking about the units. We don't have to talk about what anything means. We do want to go ahead and just think about that. A is the X, which is the area. And then C, which is F of A, is the Y, which is the cost. So if I want to talk about the units, it's a rate of change. F prime of A represents a rate of change. It's how fast whatever Y is changing. So F prime represents how fast the cost of building the house would change based on the area. So when we write the units for F prime of something, there is a prime again, then you think about what the units of Y are, and then you divide it by the units of X, which makes sense because on the other problems how we say something per day or per hour, we were doing the Y per the X. So the Y units, we're talking about cost, so it's dollars. The X units it's about the area, which is feet squared. So the units are dollars per foot squared. All right, number 6. The cost of extracting T tons of ore from a copper mine is C equals F of T dollars. What does F prime of 2,000 equals 100 mean? All right, start off. Little t is the X. And then big C is the Y. The C represents the cost. And I'm realizing that this probably right here should be a little t. That represents tons. So 2,000 is where we start, and that's the number of tons. So when there's 2,000 tons extracting, whatever Y is the thing that's increasing. So cost increases by 100, and then per whatever X is in tons, so per ton. And that's Y over X, just like we did Y over X on number 5. Which makes sense, because as you extract more tons from the copper mine, it should cost more. Alright, last problem. Suppose P equals F of T is the population of Mexico in millions, where T is the number of years since 1980. Explain the meaning. Alright, so little t is the number of years. That's X. Big P is the population. It's in millions. Keep in mind on the little t, that's years since 1980. This particular problem is probably the most difficult to think about, especially the B and the C. The A is probably not that difficult. It's the B and the C that's kind of weird. So let's start off with A. We have F prime of 6 equals 2. 6 is the X, so 6 is years. So we're saying 6 years since 1980, or in 1986. Population, which is Y, increases by whatever the Y is, 2 million per year. So every year, the population would increase by 2 million in Mexico in 1986. If the population was decreasing, that would mean there would be bunches of deaths, maybe a plague or something like that. But most of the time, population would be increasing, I would think. Now, to show you the B and C, I'm going to erase the rest of this to give you a little bit more room and so that you can understand it a little bit better. Alright, on B, there is not a prime. That is a -1. And what I want you to remember, if you have f -1 of something, that we're talking about the inverse. So f to the -1 is the inverse. Whatever is in parentheses is always whatever y is. Whatever's inside that parentheses is y. And then whatever is outside the parentheses is x. The inverse switches x and y every single time. So on B, all that has happened is that we've switched x and y. So 95.5 represents y. In this case, we know that y is a population, so 95.95 is the population in millions. And 16 is the x, which we know has to do with the t, which is the number of years since 1980. So 95.5 is the population in millions in the year 1980 plus 16, which would be 1996. So if you see inverse, all that happens is x and y switch. Nothing about a rate, nothing about how fast something is increasing or decreasing. It just switches x and y. Now, here's the really important part. C has an inverse and a prime. So we're saying we're talking about its inverse and then we're talking about a rate. Okay? Whatever's inside of parentheses is still y. So 95.5 is still the population. But this 0.46 is a rate because of the prime. And so 0.46 says that something is changing. Well, if 95.5 is the y, then instead of us saying that the millions are changing, we have to say that the years are changing. And then when we talk about how much they're changing, we have to say that they increase by, instead of saying whatever y is by every x, it's x by every y. So again, we're switching that x and y. And so it increases by 0.46 years per million. Because normally you would say the population's increasing by millions per year. Well, every word that's an x changes to a y, and every y that's a y changes to an x. So we're saying that it's going to take 0.46 years to make this population increase another million. And the way I just said that, if you'd rather say it that way instead of this way, that's okay. This is just more of the standard way so that you could get your x's and y's in order.